Ever heard of a sponge made out of metal? Sounds like something out of a sci-fi movie, right? But believe it or not, this isn't fiction. It's cutting-edge chemistry, and it's changing the world as we know it. Imagine holding a piece of metal that's so light and airy, it almost feels like it shouldn't exist. This isn't just a cool party trick for scientists. This is the kind of breakthrough that can transform entire industries and touch every part of our daily lives. The story of how we got here is as fascinating as the material itself, and it all starts with a simple question. What if we could design materials at the atomic level, building them up like tiny, invisible Lego sets? Stick around. Today's Nobel Prize story is wilder than you think. We're diving into a discovery that's not just mind-blowing, but also has the potential to reshape industries, clean up our planet, and even save lives. This is the kind of science that makes you want to grab a lab coat and join the adventure. The journey to this discovery is filled with eureka moments, setbacks, and the kind of relentless curiosity that drives scientists to keep asking, what if, long after everyone else has gone home for the night. If you've ever wondered how a single idea can ripple out to change the world, you're in the right place. So, who are the all-stars? Every year, the Nobel Prize in Chemistry shines a spotlight on the brightest minds, those who push the boundaries of what's possible. This year, the spotlight is on a trio whose work has opened up a whole new world of materials. These are the scientists who dared to dream bigger, to look beyond the obvious, and to imagine a future where the very building blocks of matter could be rearranged to solve problems we once thought were impossible. Their story is a testament to the power of collaboration, creativity, and a little bit of scientific stubbornness. This year's prize goes to 3 brilliant chemists, insert laureates' names, for inventing metal organic frameworks, or MOFs. These scientists didn't just make a new material. They created a whole new class of materials, with properties so unique that even their peers were stunned. Their work has inspired thousands of researchers around the globe, sparking a wave of innovation that's still gaining momentum. The story of MOFs is a reminder that sometimes the most revolutionary ideas come from asking the simplest questions and then refusing to accept that's impossible as an answer. Imagine building with Lego, but each block is an atom, and together they form these epic, ultra-tiny cages. These cages are so small you'd need a super-powered microscope to even glimpse them, but they're mighty in what they can do. The beauty of MOFs lies in their structure. By carefully choosing which metals and organic molecules to connect, scientists can create frameworks with precise shapes and sizes. It's like having a molecular toolkit, where you can design a material to do exactly what you want. Whether that's trapping a specific gas, catalyzing a chemical reaction, or even changing color in response to its environment. MOFs are like sponges made of metal and molecules, super light, super porous, and ready to trap all sorts of gases. Their structure is so open and airy that a single gram can have the surface area of a football field. That's right, one tiny pinch of MOF can soak up more than you'd ever imagine. This incredible surface area means MOFs can interact with huge amounts of other substances, making them perfect for jobs that require capturing, storing, or filtering molecules. It's almost like having a microscopic city with millions of tiny rooms ready to host guests of all shapes and sizes. The science behind MOFs is as elegant as it is powerful. By combining metal ions with organic linkers, researchers can create frameworks that are not only strong and stable, but also incredibly versatile. Each MOF can be tailored for a specific purpose, whether that's capturing greenhouse gases, storing energy, or even acting as a catalyst for chemical reactions. The possibilities are limited only by our imagination and the creativity of the scientists working in this field. These frameworks are designed with precision, allowing scientists to tweak their size, shape, and chemical properties. That means they can be customized for all sorts of jobs, from filtering toxic chemicals to storing clean energy. The ability to fine-tune MOFs at the molecular level is what sets them apart from other materials. It's like having a recipe book for materials science, where you can mix and match ingredients to create the perfect material for any challenge. This level of control opens up a world of possibilities, from environmental cleanup to advanced manufacturing. But why are scientists so hyped? Well, MOFs are a game changer. They're not just another cool material, they're a platform for solving some of humanity's biggest challenges. Imagine a world where we can capture pollution before it ever leaves a factory, or where we can store enough clean energy to power entire cities. MOFs make these dreams possible, and that's why researchers everywhere are racing to unlock their full potential. The excitement in the scientific community is palpable, and for good reason. MOFs could be the key to a cleaner, greener, and more sustainable future. MOFs can capture carbon dioxide, yep, the stuff heating up our planet, store clean hydrogen for futuristic cars, or even deliver life-saving drugs with surgical precision. Imagine a future where factories use MOFs to scrub pollution from their smokestacks, or where your car runs on hydrogen safely stored in a MOF tank. Hospitals could use MOFs to deliver medicine exactly where it's needed, reducing side effects and boosting effectiveness. The versatility of MOFs means they can be adapted to tackle a wide range of problems, from environmental protection to healthcare innovation. It's no wonder that industries around the world are investing heavily in MOF research, hoping to be the first to unlock the next big breakthrough. And the applications don't stop there. MOFs are being explored for water purification, where they can remove contaminants at the molecular level, making clean water more accessible to communities in need. In the world of energy, MOFs are being used to develop next-generation batteries and supercapacitors, offering the promise of faster charging and longer-lasting power. Even in the field of electronics, MOFs are showing potential as sensors that can detect everything from toxic gases to changes in humidity, opening up new possibilities for smart devices and environmental monitoring. Think of them as the Swiss Army knife of materials. One tiny framework, a million uses. From water purification to gas separation, from sensors to supercapacitors, MOFs are popping up in research labs and industries everywhere. Their adaptability is what makes them so exciting. No matter what challenge you throw at them, there's a good chance a MOF can be designed to meet it. This flexibility is driving a wave of innovation as scientists and engineers dream up new ways to harness the power of MOFs for everything from environmental cleanup to advanced manufacturing. These discoveries aren't just chemistry flexes, they're changing lives. The impact of MOFs is already being felt, and we're only scratching the surface of what's possible. In some parts of the world, MOF-based filters are being used to provide clean drinking water to communities that lack access to safe sources. In hospitals, researchers are developing MOF-based drug delivery systems that can target cancer cells with unprecedented precision, reducing side effects and improving patient outcomes. The real-world impact of MOFs is growing every day, and as more people learn about their potential, the pace of innovation is only accelerating. Cleaner air, greener energy, healthier people. MOFs are helping us tackle climate change, power the next generation of vehicles, and revolutionize medicine. It's not just about science, it's about building a better future for everyone. The promise of MOFs is that they can help us solve some of the most pressing challenges of our time, from reducing greenhouse gas emissions to making healthcare more effective and accessible. As we continue to explore the potential of these remarkable materials, the possibilities for positive change are truly limitless. The recognition of MOFs with the Nobel Prize is more than just an award. It's a signal to the world that this field is worth watching. It's a call to action for young scientists, engineers, and innovators everywhere to get involved, to ask new questions, and to push the boundaries of what's possible. The story of MOFs is still being written, and there's plenty of room for new voices and fresh ideas. Who knows? The next big breakthrough could come from someone watching this video right now. All thanks to some serious lab magic and a lot of coffee. Behind every breakthrough are years of late nights, failed experiments, and relentless curiosity. The journey to MOFs was filled with challenges, but these scientists never gave up. They faced setbacks, skepticism, and more than a few moments of doubt, but their passion for discovery kept them going. It's a reminder that science isn't always glamorous. Sometimes it's just you, a cup of coffee, and a stubborn determination to figure out how the universe works. Fun fact, some MOFs can hold more gas than a scuba tank, while being lighter than your phone. That's not just impressive, it's revolutionary. Imagine carrying a tiny device that can store enough energy to power your gadgets for days, or a filter that can clean polluted air in seconds. The potential for portable, efficient energy storage is enormous. And it could change the way we think about everything from transportation to personal electronics. The idea that something so small and light could have such a big impact is a testament to the power of smart design and innovative thinking. Imagine a future where MOFs are integrated into everyday objects, air filters that keep our homes and cities clean, wearable devices that monitor our health in real time, or even drones powered by MOF-based energy storage. The possibilities are as vast as our imagination, and the only limit is how far we're willing to push the boundaries of what's possible. As MOF technology continues to evolve, we may soon see applications that today seem like science fiction become a reality. That's science for you, always full of surprises. Just when you think you've seen it all, along comes a discovery that flips the script and opens up new possibilities. The story of MOFs is a perfect example of how curiosity, creativity, and a willingness to take risks can lead to breakthroughs that change the world. It's a reminder that the next big discovery could be just around the corner, waiting for someone to ask the right question or try something new. So, what's next for MOFs? The possibilities are endless. Maybe they'll help us create carbon-neutral cities, or invent new ways to store renewable energy. Maybe they'll even help us explore space by capturing and recycling air on long missions. The future of MOFs is limited only by our imagination, and as more people get involved in this exciting field, the pace of discovery is sure to accelerate. Whether you're a student, a scientist, or just someone who loves learning about the wonders of the universe, there's never been a better time to get curious about MOFs. Congrats to the MOF trio. And hey, what breakthrough do you hope MOFs will unlock next? Let me know below. Your ideas could inspire the next big leap in science, whether it's cleaner air, better batteries, or something we haven't even imagined yet. The future is wide open, and it's up to all of us to shape it. Like, subscribe and hit that bell for more science that'll blow your mind. Stay curious and keep exploring, because the next Nobel-worthy discovery could be just around the corner. Remember, science is a journey, not a destination, and every question you ask brings us one step closer to the next big breakthrough. Thanks for watching, and until next time, keep dreaming big.